Hi, everybody. This is Miss Kylie. Welcome to your first digital learning segment. So, this is what I'll be using to give you lectures from time to time, depending how long we're going to be in this situation. And just a reminder that, if things feel chaotic and things feel a little bit out of our control, you can always use some of the techniques that we've practiced throughout our mindful minutes to remind yourself that you can always come to the present moment, which is the only moment you can control for yourself, by taking a few deep breaths and coming to your body. With that being said, this is lecture 23. We're looking at topic 10. This is part 2. We did part 1 in school, albeit it was a little quick. So I'm going to make this lecture pretty short so that we can really focus on those functional groups and on naming organic compounds. Yes, it's a lot of material. Yes, this is crazy that we're doing everything online, but well, guess what? It's a situation. You and I do not have control in the matter, but what we can do is show up. We have a job to do. We're going to keep doing it, and we're going to do it right. So let's get started. The bell ringer. We're looking at a compound called propyl propanoate. We're trying to figure out which from A, B, C, or D is propyl propanoate. So the best thing is to go to your chapter 10, which if you don't have your book, I did upload this PDF, or I'm going to the Google Classroom stream. That means the main page, okay? And we're going to go to page 314. First, I want to show you here, in the beginning of the chapter, there's these neon green pages that show you some really quick bits of information that are extremely helpful, and you're going to want to refer to as you go on throughout this chapter and do the work that I'm assigning you. Anyhow, let's go to page 314. Here we are. And in page 315 is the other half. And we're going to notice that there is a class name given to alkanes, right? And when they show up as alkyl groups, they come out as methyl or ethyl or propyl, and they remain as the prefix in the name of the compound. So if you don't remember that from class, I'm going to show you here. Sometimes we have a long chain of carbons, right? Let's make this chain here. Here we go. And I'm going to make another C right here. And I'm going to surround these with H's. And remember that I'm going to put just straight lines to represent H's, okay? Just for the purpose of going fast. So that means that all of these lines here are H's, H atoms. And our first job is to count which is our longest chain of carbons. So I'm going to go, okay, 1, 2, 3, 4. 1, 2, 3, 4. Awesome. 1, 2, 3. That's not the longest chain. 1, 2, 3, 4. Okay, it seems that 4 is the longest chain of carbons. And if you remember from class, I wrote meet. Oh my God, this is terrible. Oh, wow, that was great. Meet probu. This helped us remember the first 4 basic alkanes. Please just bear with me with this writing aspect here, okay? So I went like this, boom and boom. And so this was methane, ethane, propane, and butane. And we have 1 carbon, 2 carbons, 3, oh my God, 3 and 4 carbons. So methane, CH4, ethane C2H6, propane C3H8, and butane C4H10. And we know the different ones because consecutive members or successive members in a homologous series contain a difference of CH2. So that means from methane to ethane, I add a C and two H's, right? Here's methane. I add another C, so it becomes C2, and I add two H's, and I get C2H6, and that's how I know what ethane is. And if I continue to add another C and another two H's, I get C3H8, and that's propane. So CH2 is the group that helps us know what the formula is of successive members in a homologous series. So back to this. I know that part of the name of this compound then is but. Somewhere in there is but, which right now looks like but. So but, because there are 1, 2, 3, 4 carbons, or 1, 2, 3, 4, it doesn't matter what way we go. There are 4 carbons in the longest chain possible in this compound. 1, 2, 3, 4, 1, 2, 3, 4. It doesn't matter which direction you choose, the name will come out the same if you have many options of the same chain, okay? So, but. Now, there is no other functional group, because if there was a functional group, I would see something weird, like an O or a weird double bond somewhere. This looks very simple, and it just has a simple substituent sticking out somewhere. So I know that the end of the name is ane. I know it's butane because it's a simple alkane that just has this random thing sticking out of it. So remember that when an H is substituted with a what we call substituent, we have to count the carbons, and we want to give the lowest numbered carbon as possible to the place where the substituent is. So let's say that we're going to count that our chain is this one here. The longest chain is this horizontal chain here, okay? That means that this guy here is the substituent. It has replaced what would have been an H. This would have been an H, and this would have just been butane, but it's not just butane because there's some weird thing that has decided to pop into it. When I look at this thing, it's a C with 3 H's. So I have CH3. CH3 looks a hell lot like CH4, which is methane. However, when you have what looks like a alkane, except it is missing one of the H's, it is what we call an alkyl group, and it takes the suffix -il. So this, instead of being methane, is methyl. Just, okay, here we go. Methyl, okay? This is a methyl. And so what I want to do is make sure I include that this is a methyl. Oh God, that looks good. Okay. So this is methyl. Okay. Methyl butane. Methyl butane. Oh my God, why did I go there? Okay. This would be methyl butane. And to be more specific, I'm going to say it is 2-methyl butane. Why did I choose the number 2? Because I chose to name the chain in this direction, or number it in this direction. If I had numbered it starting with number 1 here, 1, 2, 3, 4, then the methyl group would be on what would be the 3rd carbon. But if I number it from 1, 2, 3, 4 instead, then now the methyl group is on the 2nd carbon. The rules state that I want any substituents to be on the lowest number of the C chain as possible. So that is why I numbered it that way. If you need help with that, the best thing is to go back to lecture 22, topic 10, part 1, to take a look at the long example towards the end of the slideshow. If this ever loads, just give it a second. I happen to be really far away from the wireless, so I'm gonna move right now. This is what happens when you live in 1998 still, and you think that chokers are cool. And so you go down here. Sorry, in the background is Mr. Darmus watching the presidential debate between Bernie Sanders and Joe Biden, which I'm missing out on right now because I've decided to dedicate myself to the future. Here we go.
Mr. D rocks!
Okay, can you not please interrupt my lecture? This is taking so long. This is not good. Okay, well, as this loads, I will, you know what? I'm just going to show you a different way. Here we go. We're going to go in here. And this was your first lecture. So if you go down, you're going to see a really long example here. And this is a great one. It's actually from an old pre-IB book I had, and I just found it was very to the point. So it starts by showing you the longest chain, how to identify it, how to number it, what these methyl and propyl and ethyl groups are, these alkyl groups, and then how to name the molecule using the correct notation, the IUPAC notation, which is heavily used in your test in May. But no worries. You're going to do great. Okay. Going back, we're going to look at our bell ringer again. So looking at our bell ringer, take a look at the question. Propyl propanoate. Propyl propanoate. There's something with prop, huh? A lot of prop going on. So what is prop again? Prop is anything that has 3 chained carbons. You have meet probu pro 3 chained carbons. So let's look again here. You also have anoate. Anoate. Propyl propanoate. Anoate is something different. It must be a functional group. So you're going to go into your chapter and go to pages 314 and 315. Look for anoate. Obviously, at some point, you'll have to have these memorized, but for now, let's just use our resources. An anoate contains what's called an ester. This ester group means that somewhere within the molecule, one of the carbons is double bonded to an O, single bonded to another O, and then connected to an alkyl group. An R usually means that there is an alkyl group in the compound. An R prime usually means that there is something called a benzene ring or a phenyl group, which you and I have not looked at yet. So we're looking for something that has 2 O's in it. So go back to the lecture, and I'm already going to rule out C and D because I see that there's only 1 O right there and right there. So forget that. They are wrong. This is an anoate. This contains an ester. This has to have 2 O's in it. So this one and this one, both are options. Now let's rely on our prop to help us. we know there's a propyl group and a prop chain. A propyl group means that it looks like propane, so C3H8 is propane. Oh my God. But if it is propyl, then that means it has one less H. So there's C3H7 because it has replaced one of the hydrogens on the main chain. So that means that we're looking at something that has a C3H7 group branching off of it, and that would be the propyl, and something that has three C's connected to each other, which are then connected to an ester group. So here I have 1, 2, 3, then what looks like could be an ester group because of these two O's, and then 1, 2, 3. This is a very good candidate because it has prop and prop, so it could indeed be one of these. This one has 1, 2, 3, 4, then what might be an enoic group, and then 1, 2. This must not be the answer. 1, 2, 3, 4 would suggest butane or something with bute in it. 1 and 2 suggest ethane or something with eth in it. So this must not be the answer. Indeed, the answer is letter A. But let's build it so that you can see why. Here, I'm going to start with the CH3. Okay, I'm following this. Now another C, H and H for H2. Another CH2, C, H, H. And now there's an O and an O and a C, but we remember that O's do not bond to each other, right? O's do not bond to each other. So that must mean that this O is bonded to this C here. So I'm going to put this C, and this C must be bonded to the other O. So I'm going to put the O here. And now it has these two here. So I got rid of this, I got rid of this, I've got this. Now I'm back to CH2. It must go to another CH2. And then CH3. Now obviously there's something weird here, right? This just means that I need to get rid of this single electron here because this O actually needs another electron as well. So what I'm going to do is just double bond. Okay then, what we have here is 1, 2, 3 C's, 1, 2, 3 C's. This is obviously a functional group here. If we look at our functional groups, we're looking for something with a C, a double bonded O, and a single bonded O. We have two options. We have a carboxyl group or an ester. If it's a carboxyl, then the single bonded O should be connected to an H. If it is an ester, then the single bonded O should be connected to an alkyl group. So let's look at ours. Our single bonded O is bonded to an alkyl group. This here is propyl. Remember, propane is C3H8, so propyl must be C3H7. 1, 2, 3 C's. 1, 2, 3, 4, 5, 6, 7 H's. This is a propyl. Even if I went the other way, I wouldn't want to call it propyl because I see this double bonded O here. This C is part of the chain, so what happened here is one of the H's was replaced by a functional group. Since we have a C with a double O, a single O, and then that O bonded to an R group, meaning an alkyl, which in this case is propyl. Then this is propyl, and then this is prop, because of the 3 C's. And the suffix is anoate. C double bonded O, single bonded O to an alkyl group. This is an anoate. So indeed the answer is A. Propyl, propanoate is here. Notice that you didn't even need to do all the work I did. You could have done what we did before by remembering which groups require how many O's and how to count the C's, and then just go from there, taking out your least likely options. All right. You're going to see many structures that look like this. Oscar, can you lower that, please? Sorry, guys. All right, so you're going to see many structures that look like this. Every corner, okay, every angle is always a carbon. So here's a carbon. And you are to assume that every carbon angle contains an H bonded to it. If it doesn't have an H bonded to it, then it will tell you it will have some other group bonded to it. For right now, we don't have to get too into that. You're also going to notice that, yes, this C is bonded to another C, right? So this C is bonded here, here, and here, but then it seems to have a loose electron. What you'll learn later is that all of these C's end up with a loose electron, and these loose electrons are symbolized with that circle here. That circle is showing that these loose electrons are delocalized and constantly in motion, which allows for what this is here. It's called benzene, this phenyl group, to actually be super duper stable. However, we're not there yet, okay? So let's just look at what the question's asking. Here is a drug used to treat Alzheimer's disease. Which functional groups are present? Back to looking at our functional groups. But first, let's look at our options instead of wasting our time thinking of every functional group possible. I'm going to already take B out and D, because what the hell, people? Hydroxide, not a functional group. Hydroxide is our polyatomic ion, OH minus, and it is the alkaline or basic ion, the ion that makes substances have pHs that are higher than 7. So we are between A and C, and they both contain hydroxyl, and yes, I do see a hydroxyl group here. A hydroxyl is the functional group of an alcohol. And if you see here, it shows that an O and an H are bonded to each other and they stem off of somewhere in the compound. And then the thing ends with an ol, okay? Like ethanol or propanol or methanol. Any kind of alcohol contains a functional group called a hydroxyl. Great. So now let's look at our other options. We have a CH3O, an O, and a CH3 with an N. And our options are an ester or an ether. Of course, they're going to compare the functional groups that freaking sound the same. So if we look at our ester, we see C double bonded O, single bonded O, and an R group. Our ether shows a single O and 2 R's. Let's go back. This looks like it can be the ether, right? I definitely do not have the ester. The ester requires 2 O's. So this was actually pretty easy. Look again, ether just requires 1 O. Your ester requires 2 O's. We don't have an option that gives us 2 O's, so our answer is A. I mean C. Not ester. Our answer is C, ether, the one that requires 1 O, right here. Just checking if you're paying attention. All right, so here, Again, what the heck? Oh my God, how can she expect me to know this? I don't. I expect you at this point, though, to be able to just point out functional groups, and that's what they're expecting you to do too. They do not think that you know what the heck this is right here. They just want you to figure out which of these functional groups are in here. You have ether, ester, or carboxyl. So let's go check these out. Ether, our single O. Ester, our double O with another single O. And our carboxyl group. Carboxyl also has double O's. So how are we going to know the difference between our carboxyl and our ester? The carboxyl has a double bonded O and then a single O that bonds to an H specifically, whereas the ester might bond to something else, like an alkyl group, like CH3 or C2H5 or C3H7. So let's go back and check out what's going on. We do have a C double bonded to an O, single bonded to an O that is bonded to an H. Oh my God. This here looks just like this one. So we must have a carboxyl present. Now let's consider if it's ether or ester that is left. Here we have another C, double bonded to an O and single bonded to an O. But then the single bonded O is not bonded to an H, it's bonded to something else. So we can either go to our ether, right, or our ester. Which one do you think it is? You're right. It's carboxyl and ester. Our ether is the one that results in only having one O, which is not here whatsoever. We have two O's, one that is double bonded, one that is single bonded. This O then connects to what we call an R group, because it's connected to the rest of the compound that contains a bunch of C's and H's, and you'll learn that this is actually a phenyl group, which is one of those alkyls, okay? Good job. Next one. Which functional group is present in paracetamol? I'm sure a lot of you already went, uh-oh, there's that alcohol. Do you remember what it's called? You're right, it's a hydroxyl, and the answer indeed is hydroxyl. However, let's say you hadn't gotten there that quickly. You might have been like, oh my God, there's those N groups, right? And there are N groups. So let's take a look at them. We have an amide, an amine, and a nitrile. But for the nitrile, the N has to be triple bonded to the C. Is that the case here? No. We have a C bonded to an N, which is bonded to an H and then bonded to a carbon that is part of a phenyl group, so no. The other one is something with an NH2 group. Again, there is no NH2. It's an N with one H, but then bonded to different R groups and to some functional group here. The other N is a C bonded to an N that's then bonded to two H's. Again, that's not occurring here. So we do not have a carboxyamide, an amine, or a nitrile. What we do have present, though, is our hydroxyl group, which means this paracetamol medicine does contain a hydroxyl group within it. This is one other way that you'll see different organic structures drawn. Every edge here is a carbon. So every angle is a carbon atom. So that means here we have carbon, 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 and carbon. Great. Angles with nothing attached to them are attached to hydrogens. So that means we have H, 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 oops, H, and then here we have an H popping up here. This one has this hydroxyl group connected to it. It's also connected to this carbon here, and then it's double bonded to this oxygen here, so it doesn't have any hydrogens attached to it. This one, though, has a carbon attached to it, another carbon, and then this line here. So angles with straight lines attached to them and nothing else are attached to methyl groups. Methyl is CH, oh, that looks terrible, CH3, okay? So this is attached to CH3. Angles attached to anything else are attached to functional groups, such as this one here and this one here. Now, I said earlier, hydroxyl group, but do you agree with me? No, I was tricking you. This is actually part of a larger functional group. Take a look at the full thing here. Let's draw it out to help us see it better. We have CH3. I'm starting from here. Now this is connected to another C. So I'm going to put this C here. And I see, okay, H and H. So H, H. Then this connects to another C. Another C. And this C has an H above. And then it has a CH3 group below it. Then it connects to this other C. Beep, beep, beep. And it has an O bonded to an H. Oh, that was terrible. Hold on. Bonded to an H. Okay. And then, let's see, a double bond. No, okay. A double bond to the last O. Okay, wait. Last O here. Okay. So now, that means that we have 1, 2, 3. That's one chain. 1, 2, 3, 4. That's another chain. 1, 2, 3, 4. 1, 2, 3, 4. Okay, it looks like for sure the longest chain here is 4. The question is asking us to name this compound using IUPAC rules, so that means I'm going to rule out A and B because they are suggesting that the main chain is prop, which would mean propane, and that's C3. And we have a longest chain of 4, meaning bute is the correct answer. Now, they helped you here by showing you butanoic. That means that anoic is the suffix of the functional group. If you look for anoic here, the functional group is a carboxyl, which should contain a double bonded O, a single O that is then bonded to an H. And that is indeed what you and I discovered here. We have a carbon that's double bonded to an O. Oops, I forgot, lone pairs. And a single bonded O that is then bonded to an H. So we indeed have our anoic acid here. We then have to figure out where the hell methyl is. Is it on the second carbon or the third? So if we go, okay, 1, 2, 3, 4, then our methyl is on the second group. If we go 1, 2, 3, 4, or 1, 2, 3, 4, this wouldn't make any sense because then we would be suggesting that there's just an anoic group with a C bonded to it connected to the edge here. Therefore, we're going to go 1, 2, 3, 4. But even then, we would be suggesting the methyl group is on the third C. We always want substituents to go onto the lowest number possible. So we're going to name it 1, 2, 3, 4. Meaning we have 2-methyl butanoic acid. 2-methyl butanoic acid. Bada bing! 2-methyl butanoic acid. You always need to label where any substituents are. That means anything that replaces the H but is not a functional group. Functional groups always give suffixes to the name. Alkyl groups, which replace H's, are what will take on as substituents and need to be labeled with numbers. You're going to be able to practice that in your assignment for this week, which is due on Wednesday by 10 a.m. You have to do the circled ones here in red and have to also turn in notes with a minimum of back and front 1 page for just section 10.1. This is going to help you. Believe me, you want to do this. So you want to do number 1, A, C, and F, number 2, A and B, number 3 in its entirety, and number 4 in its entirety as well. I will post answers to you after I check for everything. And yes, in this case, I am checking for correctness, not for completion, because we have to kind of raise the bar here considering our situation. So you will find this lecture uploaded onto Google Classroom. All instructions for the assignment, which is this right here, are going to be there for you as well. A explains to you that I want notes, that they have to be handwritten, not typed. That is just to help with cheating. And they are on section 10.1, pages 305 to 325. Then you are going to answer the following questions, also by hand on a separate sheet of paper. You're going to take pictures of everything and you're going to upload it to Google Classroom by or before Wednesday, 10 a.m. If it is not, that's 10 a.m. If it is not on there by 10 a.m. Wednesday, it's going to be considered late and therefore not accepted, and you will receive a non-negotiable Z in the grade book. Once again, this is all for your benefit and my benefit. All right, guys, so thank you so much for joining me for this lecture. I hope my voice is not too annoying. Please, please, please email me if you have any questions, remembering that my email address, the easiest way to get me is through my Gmail, which is eliza.kiley@gmail.com. All right, guys, go Cavs!
Damn, this video long! Mr. D the best!
You're annoying.